Hi friends, good morning. Welcome to the GATE Academy, GATE's course booster session of Geotechnical Engineering. So we are here with the part 3 of this particular subject of GATE's core booster session. We have already completed the part 1 and part 2. So those who have missed the part 1 and part 2, the videos are available in our channel. So whatever questions we have solved, you just go through that so that your fundamental will be more strong. Okay. And let me tell you something. If you have not prepared that much, okay, now you are planning to, now just you started the preparation. Now what you can do, you can just give more focus on the part 1 and part 2. It doesn't mean that part 3 is unimportant. It's not like that. If you have not started your preparation, that's what I'm telling, because it is easy to study the part 1 and part 2 concepts, which we have already discussed. And part 3 is actually somewhat advanced geotechnical engineering regarding the pile foundation, regarding lateral earth pressure, regarding shear strength. So you should have the proper fundamental concepts to solve such questions. That's what I'm telling. Mainly in the part 1, we have just made the fundamental concepts very strong. So those who missed the videos, definitely you should watch that. Okay, definitely you will be getting so much confidence before entering into the examination hall. Okay, so please let me know who all are there. Gursaj, Khushbu, Krishna, good morning everyone. Sorry if I missed any name. Right. So in the previous session, in the part 2, we were actually discussing consolidation, right? We have discussed so many equations like this for the final settlement, for the coefficient of volume, compressibility and all. I have shown you different equations, and we have done questions based on time factor TV. We have seen how to calculate the time required for some particular degree of consolidation and all. Then I have shown you the immediate settlement equation. I told you whichever portion you have to take care while solving the question, regarding this E and mu value of the soil. So those who missed the videos, the previous parts, don't worry, the videos are available in our channel. Go and watch it, okay? Now, yes, regarding the contact pressure, I will come. Before that, we will do one question. After doing a question, we can just discuss how the settlement and contact pressure are varying under a rigid pavement or rigid footing and flexible footing. Okay, so you take down this question first. This is the second question of consolidation chapter 1. We have already done in the part 2, so try to do it. So I'm giving some time for doing it. After that, we will start discussing. Okay, so Naresh has joined. Good morning. Yeah, thank you for your comment. Share the link with your friends also, okay? Let more students watch the video. Let more students study the concepts. Let your friend also getting good score along with you, so that, as I already told you, you both can study in the same institute or study, or work in the same PSU. So I'm giving some time to solve it. After some time, I will also start solving it. Sorry. See which equation you are going to use. They are asking what is the ultimate settlement, So we have already seen different equations for ultimate settlement calculation. Now tell me, out of these 3, which you can use? See, we can use so many equations actually. I told you each thing we can substitute, and see each thing, maybe what I can tell, this delta E by 1 plus E. That also we can replace like that. We can do so many things. See, here also we have delta E by 1 plus E. So instead of delta E by 1 plus E, we can simply substitute that. That's how we are getting the first equation. Like that, all equations are more or less same. Tell me, yes, very good. Third equation we are going to use. All the things do you have? H value we have. Thickness of the layer that we have. E naught, initial void ratio, that is also given. Anything else is given? CC value not given, na? So if CC value is not given, what to do? We have to check whether they have given any data like this, whether they have given any graph, or whether they have given two different values of effective stress and the corresponding void ratio. If they are giving like that, then we can easily do. Sorry, CC is nothing but simply E2 minus E1, whatever be the difference, okay, divided by log sigma dash 1 minus log sigma dash 2. Like that we can calculate. If it is not given, but that is also not available, then what to do? What to do if they are not giving? We have a ready-made equation, somewhat like an empirical equation. If they are not giving the value of CC, that also you can remember. Okay, just to let you know that I have purposefully not given. What is that equation? If CC value, either you go for this graph, if they are giving, if it is not available, then only they can simply, I mean, in the data they may not be giving it, but they cannot give it, I mean, they may not be giving it if it is a clay soil. Otherwise they will give. Okay, for clay soil we have a ready-made equation. What is that? 0.009 into WL minus 10. Nothing but this WL stands for liquid limit. Okay, we can directly calculate like this. Actually, we have two equations. This is for undisturbed clay. This is for undisturbed clay. By default, this is our equation if no data is available. Okay, if it is a sandy soil and all, they will give in the question. Either they will directly give or they will give some data related to this particular graph. We can calculate using this equation. What is the change between CC equation and AV equation? First graph and second graph. Here in the first graph, denominator is not having log. It will be simply E2 minus E1 by sigma 1 minus sigma 2, like that. The slope. Nothing but coefficient of compressibility. We don't require, I'm simply telling. Whereas in CC, in the denominator, log also will come. Yes, very good. So this is something for undisturbed clay. If it is a disturbed clay or remolded clay, then we have an equation 007 WL minus 10. This is nothing but for remolded clay or disturbed clay. Remolded. Okay, I told you by default it is undisturbed clay. Okay, it is not a remolded. So in this case, okay, Naresh, look at the things which I have written. In this one, are we going to use 009 or 007? Look at the question whether they have given anything like it is a remolded clay or anything like that. No. Properly check it anywhere. No. Yes, very good. So 007 we are going to use. What we want to calculate? What is the ultimate settlement in the clay layer? If they are asking for sand and all, generally sand and all generally don't used to ask for consolidation. Wherever you are seeing, okay, then they will give all the data and all. Okay, in the advanced geotechnical we can study, but for clay only we generally used to take. Yes, understood. 00. Sorry, which one we are going to tell? 009. Yes, because they have not given that it is a remolded clay. If it is, then they will give. So by default 009. So you can calculate CC value now. Then what is left? Sigma final effective stress and initial effective stress. How can we calculate initial effective stress? That we have already discussed in the previous sessions, previous parts. Nothing but gamma submerged into particular depth and all. That you can properly calculate. Since two layers are there, two different values will come. You have to add it. You will be getting the initial. Only thing is final effective stress. Some of you may not be knowing that. We will check. So till that you just calculate. Tell me how much you are getting CC value. So SF, according to this given data, we are using this equation. Any equation you can use, depends on the given, okay, given data and all. So final effective stress divided by initial effective stress. See, can I write this final effective stress as, I'm just rewriting it. Can I write it like initial effective stress plus change in effective stress? What do you mean by final effective stress? Initially, we will be having some effective stress there. Now we are introducing this footing. Because of this footing, we are giving a 5000 kilonewton load. So because of this extra load, what will happen? Whatever effective stress is already there, that will increase. In our previous sessions, we have seen calculation of effective stress, capillary and all we have seen. So that is the initial effective stress calculation. Now, because of this application of load, effective stress will increase because we are applying some load, effective stress will increase. So that effective stress, increment effective stress, if you are adding with the existing one, you are going to get the final one. So can I write like this also? Okay, in some material you will see this equation. Very simple, according to what we have already studied. Yes, so CC value, tell me how much it is. By default, 009 into how much is liquid limit? Initial void ratio and liquid limit are 48%. See, this is actually 10. 10 means 10%. Okay, properly check it. It has to be substituted in percentage. So how much you are getting? 0.342. Okay, so substitute in percentage. That also you note down. Okay, that is also important. Don't take it in decimal. Then you are going to get very less value, 0 like that. So H0 we have now. H0 is how much for the clay layer? What is the initial thickness? Due to consolidation, thickness will change. Okay, that's why we are putting HO initial. So that is 5 meter we have. CC value we got. E0 also we have. Initial void ratio we have. Now calculate sigma dash. Initial effective stress you calculate. Saturated value is given. For the clay also given. Look, where is the water table? Above water table, we have to take simply gamma saturated only. Below water table, we will be taking gamma submerged. They have given water table is at ground level, so every term will be submerged only. I hope you have already seen the part 1. If not, you can watch later. So how the equation will come, I can directly take the submerged value. So for the sand, it is 22, no? Okay. So 22 minus 9.81, which is nothing but the submerged unit weight of the sand. Multiply with, what was the 8 meter. Okay. Plus 20 minus 9.81. Now tell me, how much is this width? Sorry, how much is this value? You please tell me. For the clay layer, how much we have to take? Yes, H value I'm going to give you. Tell me. Here, what value I have to put? Should I put 5? Is it? This is the place you are going to make mistake. We shouldn't put 5. Whenever they are asking what is the ultimate settlement or what is the settlement in a particular layer, what we have to do? If they are asking for some particular layer this much, we have to consider a point which is at the center of the layer. This is what you have to note down. This is where you are making mistake. Okay, so the clay layer is 5 meter. See, only for that particular layer, whatever is above, we have to consider. So sand is there 8 meter. We have to consider 8 meter. But for whichever layer they are asking, we are going to consider the middle layer. I mean, whichever is the layer, we are going to consider the midpoint of that particular layer. Clear? So what I have to substitute? So now you are getting the point, Gusaj. Okay. Clear? Yes. So 2.5 we have to substitute. Now you tell me how much you are getting the sigma dash value. Let me check my answer also. 1 second. Please comment how much you are getting for sigma dash. Let me confirm with my answer. Yes. 122. Oh, okay. I guess I have taken 1 second, guys. Can you do a favor for me? Can you just change it to 24? Nothing. If it is 22 also, no problem. I just want to confirm with my answer. Otherwise, I have to take the calculator now and check it. Okay, that's why. Can you please change it to 24? So that I can confirm with my calculation. Actual question was 24. So while I was writing there, I made a mistake. Okay, that's why. So can you please change it to 24 and calculate and tell me the answer so that I can check whether calculations are correct or not. Hope you understood why we have taken this minus. This is submerged value. Okay, this is also submerged of clay layer. This is of the sand layer. Okay, so this thing you properly note down. Okay, 138. Okay, now my calculation is also correct. 138.995 you are getting now. 138 point. Are you getting the same answer approximately? Which unit? All the things are in kilonewton per meter cube. So multiply with meter means meter square. How can I calculate the change in effective stress? Okay, thank you. How can we check the change in effective stress? Properly listen. Whenever they are giving, they will give some load distribution. Either they will give directly in the question. Are you seeing any question? I mean, are you seeing any direct value in the question? No. Or they can, what they can do, they can give you some final void ratio and all. Okay. If they are giving the final void ratio, means before application of the load and after application of the load. So either we can use the first graph or you can use the second graph using the value of AV or CC. Here we have the CC value. So if they are giving at the end of that particular consolidation on a final settlement, they can give you what is the void ratio. That will be a decreased one, so that we will be having different values. Final, what is the final void ratio that they may give, so that corresponding to final void ratio, we can calculate the final effective stress using the CC value, using this equation. That we can do. Whether they have given anything like that, no. So this is the way you have to proceed. Just look at the data. Anything is available. If not, then we have to go to the next method. If that is also not available, then we have to go for the next one. Like that. We have to check how we can extract the data. That is it. Okay, there is no predefined steps and all. You have to do this, you have to do that, nothing. Understood? You can go for any method. I can use one equation, you can use another equation, the third person can use his own equation. Finally, we are going to get the right answer, same answer only. Okay, so here this is also not available. They have not given any final void ratio. Then what we can do? They have given a next hint. Okay, some load distribution. Why they are giving this? Because they don't want to give the final void ratio, or they don't want to give you the extra effective stress happen, increased effective stress. They want us to know this concept. So what is this trapezoidal distribution? 1:2, 1 vertical is to 2 horizontal, and means they can give you any distribution. How we are going to calculate it? Simply, have you studied an equation? Q divided by B plus Z into L plus Z. Have you studied an equation like this? Have you studied an equation like this? If you have a square footing, of length L and width B, so this is B, this is L. If you want to calculate what is the effective stress, means increased effective stress due to a particular load Q at a depth Z. If they are giving some load distribution, what we can do? We are going to assume a load distribution, something like that, and we are going to check how much will be this area, which is, see, something like that I can draw, understanding what I'm drawing. So this area we are going to calculate. That is nothing but Q divided by area, and this area will be equal to B plus Z into L plus Z. Have you studied this? Yes. So can I use this equation? Can I directly use this equation? Clear? I cannot use. Why? Why I cannot use? This equation can be used if the load distribution is, look at here, if the load distribution is 1 horizontal is to 2 vertical, then I can use that. Okay, properly check it. Here what is, okay, Z value I will tell you. Now listen, how we are getting this B plus Z and all. You don't have to by heart anything. Simply look here. See what actually happening here. If I'm simply drawing the side view, we have something like this we have, and now let it be, this is our B value. Okay, the width value, length we have on that side. Okay, let it be like that. Now if there is a distribution happening which is 1 horizontal is to 1 vertical, generally This is what they used to give in the question. I was just making a modification, just a twist. I just want to let you know that, or properly check that. They can make a level 3 type of question. Okay. If they are giving a load distribution of 1 horizontal is to 1 vertical, sorry, 2 vertical, what is the meaning of this? What is the meaning of this? If you are moving 1 horizontal, you have 2 vertical. Or if you are moving 1 vertical, you have half horizontal. Enough? How much, for how much depth you want to know? What is the effective stress? At a depth of Z. Now, can you tell me then, how much will be this? How much will be this horizontal? If for 2 vertical, we have 1 horizontal. Now you tell me, everyone, then for Z horizontal, sorry, for Z vertical, how much we will be having horizontally? That's it, 0.5 Z, enough, Z by 2. Correct now? So similarly here also, how much will be having? So it will not be this much wider. Okay, only half of that. Now somewhat like this is our distribution. So here also we are getting 0.5 Z. Enough? Now you tell me, what is this total width? What is the total width of the area which is subjecting under load? What is that? 0.5 Z plus this B value plus 0.5 Z. How much it will be? B plus Z. Correct? Correct? Are you getting it or not? Yes. Similarly, here, if this is B, sorry, suppose if this is L, or if you want, okay, we can just take it as L only, no problem, so that you can just compare with the above figure. So I'm going to get L plus Z. Similarly, here we have B. There also I will be getting B plus Z. So we are getting a new square, no, large square. What? Sorry, rectangle. What will be the area of the rectangle? B plus Z into L plus Z. As simple as that. Clear? Yes. So Naresh, now you're understanding. That's what you don't have to by heart. Okay. If you're understanding now, see, if you're by hearting and studying 100 concept, it's better to understand and study some 5-10 concept. Enough. At least you will be getting the mark from that 10 concept rather than going beyond so many concepts. Now, just study properly what you are studying. Okay. Enough for scoring good mark. You don't have to score 100 out of 100, 90 out of 100 and all. No? You will be getting good rank even if you are scoring 60, 70 mark. Okay, so properly understand and study. Then whatever twist they are making in the question, you can easily solve. Clear? Now, can I use this? Can I use this Q by B plus Z plus L into L plus Z? No, because here the distribution is different. It is 1 vertical is to 2 horizontal. Now you tell me what it will be. If it is 1 horizontal, okay, here I'm just drawing it. So the same thing, it is L. Now what they are telling in the question, 1 vertical. So this is 1 vertical is to 2 horizontal. Enough? Now tell me, for a depth of Z, for a depth of Z, this is Z. Tell me how much will be horizontal. Everyone please comment. How much will be horizontal? How much extra will come here? For 1 vertical, we have 2 horizontal. So here we will be getting, very good, 2Z. Enough? Like this. According to this particular distribution, 2Z. Getting or not? Getting or not? Now what will be the size of the new one? L plus 2Z here, 2Z here. So L plus 4Z. Similarly, in the width, we will be getting B plus 4Z. Are you understanding, guys? So don't simply by heart. Properly check it. Most of the time, 95% of the time, they will give 1 horizontal is to 2 vertical. Okay, that is standard. I just want to let you know that simply blindly on the question, just check it. They can easily make a deviation. Is it clear? Is it clear? Prachi, I think you joined a little bit late. I have explained here simply. Whatever is the width and length depends upon the distribution they are giving. Simply 1 horizontal, 2 vertical means what? For 1 horizontal value, we have to make this like that. Similarly, they have given in this question, one vertical is to 2 horizontal is the distribution. Means if we are going one vertical, we have to now we this So hi guys, are you able to see now? Sorry for the mistake happened from my side. Can you please everyone comment? Is it okay now? Yes, okay, thank you. Don't know, I think it's regarding some internet connectivity maybe. Okay, so have you solved it? Are you getting the area? Okay, thank you. Sorry for that delay. So how much will be getting now? This value are you getting? Tell me how much is Z value? How much is Z value? Now see guys, it's a square, no? 1.8 into 1.8. So both B and L are same, 1.8 only. So we can directly take 4 into, what is that Z value? Everyone please tell me. Z value, I already told you, when they are asking the middle, we have to, when they are asking a layer, we have to take that middle value, mid portion. So how much will be Z value? Yes, 8 plus, this will be 2.5. So for calculating the effective stress as well as for taking the Z value, 8 plus 2.5. So totally it will be, Z will be 10.5. Now, yes. So substitute there 4 into 10.5. Can I take square directly? Because it is same. If it is a square, then directly same. So that is going to be 2.606 around. So substitute back in our original equation. Yes, very good. Substitute back. How much you are getting? Everyone, please tell me. H naught is equal to, see, H naught you have to take 5 only. Here, this value is 5. Okay, only in the calculation of effective stress. And here Z, we have to take that midpoint. H naught is the original initial thickness. So tell me H naught, 5 meter. Yes. So substitute and tell me how much you are getting SF now. Are you getting the same answer? 7.2? 5,000? 5,000, okay, 5,000, fine. Sorry. Same, answer is same only. I have written by mistake. Okay, thank you. Same na, 2.606. Are you getting 7.2 something? Everyone please comment how much you are getting final answer. Okay. How much? -3, but that will be in meter. No, everything we are substituting in meter. Your H value, everything we are substituting in meter. Okay. The value of SF, the unit, all other thing units are going to get cancelled. Sigma F and all, because it is log. You know. So that is going to be 7.26 mm. Getting? Everyone please comment. Is there anything different from my calculation? Did I make any mistake? Everyone please comment now so that I can compare my answer. Yes, are you getting the same? Please comment everyone. Yes, correct. Okay, very good. So all the value, I'm not substituting again everything, nothing but H naught is 5 meter into CC value we calculated as 0.342 something. 1 plus E naught is how much? 0.9. Then log, remember here we have to take the completed depth, I already told you. Then final value will be how much? Initial effective stress 138.995 plus 2.606 is the final one divided by 138.995. Correct now? That's it. 7.4. Okay, approximately 7 point something. If you are getting, it will be correct. It depends on how accurately you are taking the logo value and all. 7 point something will be correct now. Okay. Right. Now I'm just showing you that that point which you asked in the previous session. This one. This you simply remember. See, under a rigid footing, settlement and contact pressure. Similarly, under a flexible footing, settlement and contact pressure. These are generally asking in which of the following statements are true. Like that, they can ask easily. What you can do, simply remember only one. The remaining one will be, the next one will be completely opposite. So if you are by hearting only rigid footing, just remember rigid footing means under the rigid footing, whether it is a clay or whether it is a sandy soil, settlement will be uniform. Means if I have a particular footing, suppose if this is the footing, if load is applying, the footing will be having a tendency to settle uniform throughout like this. It will not bend. It will be throughout uniform settlement. That if it is a rigid footing. Okay, then completely opposite flexible, that will be different. Okay, that how it is different, that we are going to study. We have settlement as well as contact pressure. Settlement is uniform in rigid footing, so that opposite thing, what is opposite thing, contact pressure will be uniform in flexible pavement. Okay, like that you can remember. Now coming to contact pressure, you somehow you remember whatever, it's up to you. You can simply remember in contact, if it is the contact pressure in sand, it will smile. Okay, something like that you can remember. Okay, contact pressure likes rigid footing, so it will smile. If this is the footing, how they can ask the question, the distribution is like this, which means maximum contact pressure will come at the center and minimum contact pressure at the edge. So like that only they are going to ask. Okay, understood? Now suppose if here is the footing, if it is clay, what will happen? Maximum contact pressure will be at the edge. See, like this is how they are going to use this. Maximum contact pressure will be coming at the edge, minimum at the center. Okay, understood? Simply you can remember contact pressure under rigid footing, in sand it will smile like that. Okay, completely opposite thing will come in the flexible pavement. But remember, in flexible pavement, contact pressure is uniform, settlement is different. Okay, you just remember for the rigid footing so that you can just compare with the flexible footing and remember. Clear? Vaishnavi, natural logarithm we are not using anywhere. Log only we are using. If we are using natural logarithm and all, that will be where in well hydraulics portion, natural logarithm is coming, and in where it is variable head test in permeability also, natural logarithm is coming. So like that in some area you have to check. That's why you have to write some short notes. Yeah. Hope now it is okay. I'm sorry, I'm getting trouble from my side due to internet connectivity. I hope you will not miss anything. Okay, don't worry. So this question we have already solved. Now, yes, do this question fast. Now I think we have to go a little bit faster, okay, because we lost some time. So do this question. I hope the previous one is clear now. Do this one, everyone. Something related to shear strength and all. Yes, Praji, natural logarithm will be used in permeability, variable head test, and also in well hydraulics. We have discussed that in hydrology irrigation session. You can watch that. In well hydraulics, for checking the yield of an aquifer, there also we can use natural logarithm. See, wherever we are using natural logarithm, in the same place we can use log also, log 10, but 2.303 will come extra. That's it. If you are seeing 2.303 and all somewhere, which means it is actually conversion of natural logarithm into log. Okay. Clear? Okay, thank you. Now you see, I'm just showing you some equation. Very, very important. Whatever, see, this is, whenever I was studying also, my friends also used to skip these portions by looking at the equations. Lots of equations are there under shear strength. If you are getting confusion, you just study to just one equation or two equations, nothing but this one. Second one, no need to study. Sigma 1, sigma 3 stands for principal stresses. Okay, we have, see, in every body, just remember, just listen to me. In every body, in every rigid body, see, suppose if this is a rigid body or any stressed body, there will be three planes under which shear strength will be zero. Shear stress will be zero. There will be three planes. There will be three planes where shear stress will be zero. These three planes are called as principal planes. So, and these planes will be always perpendicular to each other, on which shear stresses are zero. Okay, and one is called as major principal plane, other one is called as minor principal plane, the other one is known as intermediate principal plane. We don't require this intermediate principal plane, we only require major principal plane and minor principal plane. On this, the stresses, the compressive stresses, we are just calling it as, it is actually compressive stress, but we'll take it as positive because in soil mechanics, all the loads are compressive. Generally, in strength of materials, compressive force we used to take negative. But in soil, since majority of the loads are compressive, we'll take compressive force as positive only in soil mechanics. So sigma 1 is the compressive force on this major principal plane. We can call it as major principal stress. Sigma 3 is the compressive stress on this minor principal plane. We can call it as minor principal stress. So sigma 1, sigma 3, the relationship between those, you have to remember, it is important. 45 plus 5 by 2. Sometimes you can see, instead of 45 plus 5 by 2, we will write sigma f is nothing but, it is the angle the failure plane makes with the major principal plane. Okay. Sigma f is nothing but equal to 45 plus 5 by 2. This is actually the angle. Just note down, those who don't know. This is the angle which the failure plane makes with this major principal plane. Okay. Now, only this equation you remember. If you are simply replacing sigma 1 and sigma 3, then three places we have plus sign. Now, all these things will become minus. That's all. Okay. Simply only remember the first one. For doing calculation, we don't require second one. Why I have written? Suppose if they are asking which of the following equation is true, then they can ask you the second one also. Then you can just remember it. Clear? Now these two equations also you remember. So first one, then these two equations. Enough. On any plane which is at an angle theta degree with the major principal plane. If I'm asking if it is a failure plane, then that theta is equal to 45 plus 5 by 2. Okay, similar to that, if any plane we have which is at a theta angle with the major principal plane, if they are asking what is the normal stress on that particular plane, what is the shear stress on that particular plane, we can substitute this equation, as simple as that. Okay, now can you tell me when we are going to get maximum shear stress? When we will be getting maximum shear stress? Whenever this sine 2 theta is maximum. Hena, what is the maximum value of sine? What is the maximum value of sine? Obviously 1, sine or cos, whatever, 1. When sine 2 theta will become 1? Whenever theta is becoming 45 degree, as simple as that. Enough. So if they are asking what is the maximum shear stress happening on a body, then what we can do? Simply substitute theta 45 degree. What will be the equation? Sigma 1 minus sigma 3 by 2. Understanding? So no need to by heart these equations. Generally in materials, they will write everything. So don't by heart anything. Simply remember the first equation, second equation, third equation. That's it. Now, if they are asking so many things, no need to by heart the equation. We are going to make it. Clear? Okay. So theta will be 45. So sine 2 theta will become sine 91. Clear now? Tau max. Okay. Now go to the first question. Now one more thing I can tell. If it is triaxial test now, so if it is an undrained test, if it is an undrained test, which means what is the meaning of undrained? Water is already there. It is not drained. Opposite of draining, undraining. Undrained test means the equation will become, sometimes we'll take in terms of effective stress, sometimes in total stress. Equation will become sigma 1 minus u is equal to sigma 3 minus u, like effective stress. Effective stress is sigma minus u now, like that. Then tan square 45 plus 5 by 2, like that. If it is an undrained test. So if it is an undrained test, they can ask you what is the pore pressure. They can give you sigma 1 and everything. They can simply ask you. One more thing you can remember. You should remember the sigma 1. We can also write it as sigma 3 plus sigma d. This sigma 3 stands for confined stress, lateral confined stress, which we are giving on all the sides on a triaxial test. This is sigma 3. Then after giving this confining stress sigma 3, we are going to give some deviator stress sigma d. Okay. And this is nothing but sigma 3 plus sigma d is nothing but our sigma 1. Okay. So either they can ask you what is the major principal stress by giving sigma 3 and so on, or they can ask you what is sigma 3 minor principal stress by giving the other values, or they can ask you what is the deviator stress sigma d. Clear? If it is a drained test, consolidated drained test and all, then pore water pressure is not there. If it is an undrained test, u also will come. So you can substitute u there. Then after solving it, you will be getting u. Very simple. Okay, so study this particular equation, first one. Study these two equations enough. And just to remember, sigma 1 is equal to sigma 3 plus sigma d. You can solve a lot of questions based on triaxial test. Lot of questions are there in the previous years. So can you solve it fast? Angle of internal friction. How can we calculate angle of internal friction? Just calculate this angle alpha f 45 plus 5 by 2, so that you will be getting what is that angle. So from there you can calculate angle of internal friction phi. Clear? Yes, very good. Now see guys, to solve this we require the C value now. Whether they have given any C value, whether they have given any C value, cohesion value. It is a clay, no? So if it was a sand, we know cohesion is equal to 0 for a sand. But for a clay, definitely some C value will be there, no? But they have not given any C value. Specimen has failed at a deviator stress. Sigma D is given 250. Cell pressure is nothing but confining pressure. Another name of confining pressure, sigma 3, 220. These two are the data we have. C value, yes, very good, very good. This is another point you have to remember. Normally consolidated clay. If it is over consolidated clay, then definitely C value is there. For a normally consolidated clay, practically it is having a C value, cohesion value is there. But in a triaxial test, a normally consolidated clay will act like a sand. It's not a sand, he's having cohesion actually, but in a triaxial test, a normally consolidated clay will act like a sand. So that we'll take, for a normally consolidated clay, we'll take C is equal to 0. Clear? That is very, very important. If it was an OCC clay, over consolidated, then we have to take C also, then they have to give. Clear? So that generally we have an equation, shear strength is equal to C plus sigma tan phi. And now for an over consolidated clay, we have to take C plus sigma tan phi. But for an NCC, normally consolidated clay, we'll simply take sigma tan phi only. Whereas for a sand and all, phi value is 0. Like that, we have to study concepts, different values for each thing. Yes, very good, very good. So calculate and tell me. So you just substitute in the equation. How can we substitute? Sigma D we have, sigma 3 we have. So that we will be getting sigma 1 now. Sigma D plus sigma 3 is nothing but sigma 1, 470. Na? So substitute in the equation and tell me how much it will be. Everyone tell me how much is the phi value you are getting. 470 is equal to 220 tan square 45 plus 5 by 2. Please calculate and tell me how much it will be. You are going to get C if I am substituting alpha f simply. Why this f? Because of failure plane making an angle. Na? So generally we give a notation alpha f. So that 45 plus 5 by 2 or alpha f, you are going to get it as 55.62 I think, which means you are getting phi is equal to 21.24. And are you getting the same answer? Yes, Krishna, you are correct. Guys, please comment so that I can confirm my answer also. Okay. Now, what is the second one? Normal stress on the failure plane. What is the normal stress on the failure plane? We know normal stress on any plane is this. Then what will be normal stress on the failure plane? What will be normal stress on the failure plane? I have to substitute theta is equal to. Yes. Normal stress on failure plane means I have to substitute theta is equal to 45 plus 5 by 2. That's what I told you here. This is nothing but the failure plane angle with the major principal plane. So substitute 45 plus 5 by 2 in terms of theta. So cos 2 into 45 plus 5 by 2 will come. Phi value we already calculated, or 45 plus 5 by 2 we have already having. Substitute and tell me how much it will be. Everyone, what will be the equation then? Sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 into that answer. How much you are getting? 299. Yes, very good. So sigma 1 plus sigma 3 by 2, sigma 1 minus sigma 3 by 2 cos 2 into 55 plus 55.62. So you are going to get 299.71. Very good. So is that option is correct? We got the first option as correct now. Second option is wrong. We got 290 and all. Correct now? Yes, Vaishnavi, you are correct. Correct. Okay, if it is undrained test, then this one also will come. U also will come. Pore water pressure will also come. Then they will give that. Either they will give in the question. If they are giving that it is an undrained test, they will give pore water pressure also in the question. Then everywhere we have to substitute. In the sense, in this equation, what will come? In place of sigma 3, it will be 220 minus U. In place of sigma 1, it will be what it will be 220 minus U plus 250 minus U. So 2 times minus U will come in sigma 1 like that. If you are calculating based on sigma 3 and sigma D. Understanding? Okay. So similar to that, you will be getting lot of questions. See, you will be getting the Kannan Gesto textbook for downloading from Google and all. Just download it. There are a lot of questions in Kannan Gesto. I mean, not in Kannan Gesto. That is for transportation. Aurora textbook is there. Lots of others textbooks are there. Punmiya textbook is there. Okay. So just check it. Lot of questions are available. If you want, I can just add a link to the comment box also. You can just watch it. I mean, you can just download it and read it. Okay, just for understanding small concept, reading the textbook is good. Not simply reading, just refer the textbook. Don't waste your time by reading the textbook. Shear strength on the failure plane will be what? What will be the shear stress on the failure plane? Shear stress is sigma 1 minus sigma 3 by 2 sine 2 into. So substitute the value 45 plus 5 by 2. Now tell me what will be the shear stress on failure plane? Everyone, let me check my answer. How much you are getting? Simply just substitute 470 minus 220 by 2 into sine 2 into that one. 55 plus 55.62. Yes, 116.5. Yes, very good. So 116.5. Hope all are getting it. That's why I'm not writing everything. Yes. So if anyone is not getting, simply equations are available. Failure plane means theta is equal to 45. For failure plane, then it will be sine 2 into 45 plus 5 by 2. Okay. Yes. What is the last one? Normal stress on the plane of maximum shear stress. Where is the plane of maximum shear stress? What is the angle for the maximum shear stress? 45 degree. That we have already seen. Which means if theta is equal to 45 degree, then what will be the normal stress? Enough? So substitute theta equal to 45 degree. That's it. Very simple. Sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 into 45. So cos 90 will be 0. So finally, what will be the equation? What will be the equation for this one? Sigma 1 plus sigma 3 by 2. Enough? So like this, we will see a lot of equations. No need to by heart those things. Okay, na? Where angle is given, angle is not given, we have calculated in the first option A. Now we have calculated now option A. See here, angle. Clear, Prachi? Here what they are telling, normal stress on the plane of maximum shear stress. Here we have discussed when we are getting maximum shear stress, whenever theta is equal to 45 degree, we are getting maximum shear stress. So on a plane which is at 45 degree, we are getting maximum shear stress. Is it clear? Okay. Yes. So D will be sigma 1 plus sigma 3 by 2. How much you are getting sigma 1 plus sigma 3 by 2? 345, no? Yes, 345 is given in the option. So you are getting A and D as the right answer. Raji, is it clear? How to get the angle and all? Okay. Angle of internal friction we calculated, but for fourth option, we know from this shear stress equation that is going to be 45 degree. Clear? 345. So that will be correct. If it was undrained test, everywhere sigma 1, we have to replace in the equation sigma 1 minus u. Sigma 3, we have to replace. See, if they are asking what is the major principal stress, that is sigma 1 only. If they are asking you what is the minor principal stress, that is sigma 3 only. We will not see, major principal stress is not changing. Major principal stress is sigma 1. Okay. But while substituting in the equation, what we have to do? Sigma 1 minus u is equal to sigma 3 minus u into tan square 45 plus 5 by 2. Like that it will, we have to substitute like this. 2c tan 45 plus 5 by 2. Understanding? Okay. Clear? Krishna, I think you are asking regarding the other. I will tell you that. I didn't get what you are asking. Clear? Is it clear, everyone? Sometimes they will not be giving you sigma D value. They can give you cell pressure and sigma 1 value. So that using this equation, you can take sigma D. Clear, no? Now, just look at the equation of Wayne shear test. S is equal to capital T by pi d square h by 2 plus d by 6. H is the equation, H is the height of the specimen that we are taking. D is the diameter of the cylindrical specimen that we are taking, not specimen. It is the equipment, okay, that we are taking, diameter. Then T is the torque that we are going to produce for making a shear failure for the soil. I hope you have already checked this equation. Direct substitution, only special case will come when our specimen is, see, if this is the thing, first case is the complete specimen is under the ground. Okay, this is H, this is D. In the second case, sometimes our specimen, half of the instrument is above, not half, some part of the instrument is above the soil. Then also we can make the rotation here. So in that case, this small h is nothing but whichever portion is below the soil. That is the only change. Instead of d by 6, it will become d by 12. Half of that value will come. Okay, d by 6 will become d by 12. Okay, so this thing you just note down, and sensitivity is nothing but undisturbed, the shear strength of an undisturbed sample divided by shear strength of a remolded. Remolded means disturbed. We have already seen these words before, 009 and all for CC. Similarly, shear strength for an undisturbed divided by shear strength for a disturbed sample is known as sensitivity. Okay, so these things can be asked for simply 1 mark and all. When shear test, you just check it. All the things are direct substitution. Either they can ask you the shear strength, or they can simply ask you some torque required or some diameter or something like that. Properly check it. Okay, this is the only difference. If some part of the equipment is above the ground level, then the complete height of equipment or soil sample we are not going to consider. We'll consider only the, so this is case 1, this is case 2, only the portion which is under soil. Okay, that is the only thing you have to note down. Simply check it. Now it's not okay. One thing I will discuss, stress path, which I got doubts a lot of times in our LMS and all. Stress path means very simple. Either we can draw for a total stress path or effective stress path. If it is effective stress path, instead of sigma 1, sigma 3, we'll be have effective stress. Okay, sigma 1 dash, sigma 3 like that. Simply it is a representation of some maximum shear stresses. Simply remember, if you are drawing a graph with sigma 1 minus sigma 3 by 2 on the y-axis, sigma 1 plus sigma 3 by 2 on the x-axis, we are going to get a straight line. We are assuming it as a straight line. It is actually locus of maximum shear stresses. Okay, stress path means it's actually locus. If you are changing the load value, what is the change in the shear stress, like that we are going to calculate. That much a deep concept, leave it. Simply remember, we have a graph like this. This is the equation of stress path. For competitive exam point of view, what we need to study, how we are going to calculate the cohesion value, how we are going to calculate the angle of internal friction. Nothing but shear strength parameters. They will ask the shear strength parameters C and phi are respectively dash and dash, like that they can ask. So this is the way we are going to write the equation of a stress path. Here Q stands for sigma 1 minus sigma 3 by 2. P stands for sigma 1 plus sigma 3 by 2. As simple as that. For example, if they are telling, see, I have written one sentence here. The equation of a stress path is given by Q is equal to 10 root 3 plus 0.5 P. It's an example. Okay, it's a question. What will be the shear strength parameters C and phi? If they are asking such a question, how can we calculate? What you will do? Very simple. If you remember this general equation, we can easily calculate. How can we calculate? Can you calculate and tell me? Which one I can easily put? I can easily put P sin phi is equal to P sin phi is equal to 0.5 P. Similarly, C cos phi is equal to 10 root 3. Enough, two equations we can make. So in this equation, two unknowns we have C and phi. But in the first equation, we have only one unknown phi. P and P will get cancels. We will be getting sin phi is equal to 0.5. As simple as that. Whatever equation they are giving, we can calculate. Can you tell me how much is phi then? How much is phi? That's it, 30 degree. And sin 30 is equal to 0.5. Very simple. Now that phi we can substitute here. C will be equal to 10 root 3 divided by cos 30. Cos 30 will come in the denominator. How much will be C? Everyone please comment. 20, yeah? Yes. Cos 30 is root 3 by 2. Root 3 will get cancelled. So 20 kilonewton per meter square. That's it. As simple as that. As of now, we don't know whether it is kilonewton or not. They will give in the options. Okay. It will be. Okay. Depends on in the same unit only. They will give the options. Understanding? So everyone understood. Those who were having doubts in stress path, understood how to calculate the shear strength parameters. Okay, whatever equation they are giving, just compare with our original equation. That's all. Everyone please comment. Is it clear? Yes, very good. Now do one thing. Yes, do this question. Be a little bit fast since we lost some time. how to calculate for an infinite slope, how to calculate the factor of safety that you should remember for an infinite slope, and as well as for a finite slope. We are going to calculate some phi equal to 0 method and all. It's very simple. You can study. Just go through the question and understand what to do and start solving it. First one is under dry condition. So start solving it, everyone. Under dry condition, we will not be having any gamma values and all. It will get cancels. Directly we will be getting tan phi by tan I. Properly check it. No need to look at the screen and all. I'm just writing the general equation. Whereas I is the angle of slope and phi is the angle of internal friction. Video. Okay, sorry. Yes. For a sand soil, cohesion is 0. So that C value will become 0. Gamma z, everything will become cancels. So if cohesion is 0, finally it is going to be, if it is in dry, okay, gamma and all we have to take properly, gamma submerged, gamma saturated and all. For a dry soil, finally, the factor of safety will become tan phi by tan I. Whereas tan phi or phi is the angle of internal friction, I is the angle of slope. Okay. So how much you are getting, please comment. Okay, very good. So what they have given, factor of safety is given. Okay. Now what will be the safe slope? So factor of safety, if it is giving, then either one angle they have to give. Internal friction is given as 30. So what is the meaning of this? 1.3 is equal to tan 30 now. Angle of internal friction is given tan 30 divided by angle of slope is tan I. Under dry condition, note down these equations, okay? But I will be equal to, how much you are getting, guys? 23.9. Okay, thank you. 23.94 approximately. Yes. Okay. Good. Now, what is the second one? Factor of safety. Another factor of safety is given. What will be the safe angle? If it is dry, we already calculated. Seepage occurs parallel to the surface of the slope at 10 parallel. In the sense, if we have the slope something like this, okay, water table may happen or may not happen. Okay. Yes. We are going to have complete water now. Seepage is happening at and parallel to the surface. So if seepage is happening at and parallel to the surface, what will be the equation? The numerator we have shear strength. For shear strength, we have to take the submerged value. Very important, don't interchange. In the numerator, sorry, in the denominator, we have gamma saturated. In the numerator, we have shear strength by shear stress, okay? Tan I. So if seepage happens, this is our equation. You can just remember it is. See, it is at or near the slope, means it's at the top complete portion. If it is somewhere here, in between we have water table and all. We have, that's what I have written as the third question that we'll discuss there. How much you are getting? So that, yes, we have to calculate the value now. They have not given anything. Specific gravity is given 2.65. Anything else is given? Porosity is given. Okay. Which means instead of giving you the E value, I told now before, gamma saturated is equal to gamma W into G plus E divided by 1 plus E. Remembering how to calculate E from N? Any equation you can remember? I used to remember 1 by N minus 1 by E equal to 1. Anything you can remember, up to you. Tell me how much it is. 0.6. Are you getting same answer, everyone? So is equal to N divided by 1 minus N. Are you getting, everyone? Please tell me. I haven't calculated this. Okay, thank you. 0.6. So E value I got. Now we can directly substitute gamma W 9.81. If you are putting in kilonewton per meter square, okay? 2.65. How much you are getting gamma saturated? Are you getting the same value? Are you getting the same value? Okay, thank you. So gamma submerged will be then gamma saturated minus gamma W 10.11. Yes. Enough. So substitute here. Take the answer. What we need to calculate? What will be the factor of safety we have to calculate? If seepage occurs parallel to the slope with a water table at a depth of 2 meters from the soil surface. No. Second question we are solving now. Yes, 1.2 is equal to 1.2 is equal to tan 30 divided by 19.926 tan I. Enough? Tell me how much is I value? 16. Are you getting 16? Factor of safety, I have kept it as 1.2 for the second question. Properly check. It's not 1.3. How much will be I value? Everyone please comment by calculating. 13.72 are you getting? Whether I have made any mistake? 13 point something if you are getting, that will be correct. It depends on how accurately you have taken the data. Getting, everyone? Okay, 13.7. Okay, fine. Okay, approximately, if you're, it depends on how accurate you are taking this tan angle or not. Now what will be the third case? Now they are telling that 2 meters below, now the seepage is not happening surface. Seepage occurs parallel to the slope with the water table at 2 meters from. Previously they have told at and parallel to the surface. At the surface seepage was happening. So completely it was under submerged condition. That's why we have taken the equation like that. Now we have at 2 meters from the soil surface. Totally how much it is? Totally, no, they are asking at a depth of 5 meters only. Okay, then no issue. So at 5 meters we have to check here what is the factor of safety. They told that 2 meters we have water table, so that seepage is also happening here. Now how can we take the equation? Factor of safety is equal to, now here the value is not under submerged condition. In the second case they told seepage is happening at the, so here gamma D into 2 meters will come, then gamma submerged into how much will be remaining? Total it is 5 meters, 3 meters. So into 3, remaining things will remain same. Gamma 5 divided by, here also gamma D into 2, gamma saturated. Numerator it will be saturated, denominator, numerator it will be submerged, denominator it will be saturated terms. Okay, and I. So substitute everything. So that gamma D also we have to calculate. Calculate gamma D. If you're calculating gamma D, I think I am getting around 16.2248. So tell me how much is I value. Sorry, everything is given in the question now. Factor of safety we have to calculate. Given angle of slope is 20 degree. That is given in the question. I value is given. So 30 degree here, 20 degree here. Gamma saturated, everything we calculated. Thank you. 1.08. Getting clear? Is it clear, everyone? All are getting? Okay. Please comment your answer. How much you are getting, everyone? 1.08. Yes, very good, Krishna. Getting now? Okay. Now see, guys. Suppose if it was, if the water table, some extra point I'm telling. Here we have taken dry, na? Suppose initially the water table was somewhere here. Okay. Then suddenly the water table has dropped down. Sudden drawdown we call. Okay. If some sudden drawdown is happening and the water table has reached somewhere here. Okay. So will you take gamma D here or will you take gamma saturated here? Water table has dropped down. So in this case, we have taken gamma D only. So like this, if they are giving sudden drawdown, will you take gamma dry or will you take gamma saturated? What you have to do, that is actually a special case that you have to remember. What we will do? Yes, very good. We have to take gamma saturated under sudden drawdown condition. Even though water table is coming down, we assume that the soil will be still under saturated condition. We have to take it. Okay, gamma saturated value we have to consider. We will not take gamma D and no. Clear? Okay, even if it is coming down. Okay, that we just calculated. Yes, very good. Okay, that is only the special case. If you have any doubt, you can ask me. Okay, in the comment box, I will let you know. Okay, so much explanation I'm not giving because of the time constraints. Since we lost a lot of time, that's why in between. Okay. Hope you're understanding it, enough? Yes. Okay. Thank you. Now do this question then. Little bit more calculations you may have to do. Properly do it. Tell me how much you are getting. The resultant active earth force per meter length of the retaining wall. Properly take down the data. Prachi, I didn't get to what you're asking. Factor of safety 1/2. Gamma submerged by gamma saturated will not be 1/2. That is actually gamma submerged by gamma W may be approximately equal to half. Submerged by gamma W and all. I mean, yeah, okay. If they are giving the gamma saturated value in the question, that we are actually taking approximately in practical cases. Na? Others just proceed. I'm just replying to a doubt came. Okay, if they are giving the values, then we have to calculate and substitute always. Don't take approximate answers. Okay. Understood? Yes. So have you start solving this question? If they're giving, always take the accurate answer. Okay. Have you started solving it? Active earth pressure force. So definitely we have to take the active earth pressure coefficient AA. So take the data first. Surcharge is 15 kilonewton per meter square. Retaining wall total height is 6 meter. Top 2 meter is sand. Bottom 4 meter is C5 soil. So this is the given thing. So how can we calculate the effective stress? Sorry, the active earth pressure. We have to draw the active earth pressure diagram now. So always it's recommended to draw separately. This is how I used to do. It's up to you how you have studied. That like that you can study. Like that you can draw, no problem. So I'm drawing according to like whatever I have practiced. So first of all, they have given a surcharge of 15 kilonewton per meter square. So remember, whenever they are giving a surcharge, there will be a uniform earth pressure in the first layer, in the second layer also. First I'm simply drawing in the first layer, how much it will be. Since we have two layers, we will be having two active earth pressures, K1 and K2. What is the equation of Ka, active earth pressure? 1 minus sine phi divided by 1 plus sine phi. So for Ka1, it will be 1 minus sine 30 divided by 1 plus sine 30. I'm going to get 0.5 divided by 1 plus 0.5, 1 by 3. Okay. So Ka into Q will come for a active earth stress, no? Pressure will be Ka1 into Q on this first layer. It will be having Ka2 into Q in the second layer. So here it will be Ka2 into Q. Hena, how much will be that values? 1 by 3 into 15. That is going to be 5. Here it will be, how much will be Ka2? How much will be Ka2? 1 minus sine 20 divided by 1 plus sine 20. Can you please tell me how much it is? How much is Ka2? Yes. 7.35, no? Sorry, 0.49. Okay, thank you. Thank you so much. 0.49. So that how much is this value? Guys, I hope the font size is okay. What I'm writing here. This will be Ka2 into Q. How much you are getting? 7.49 into 15. 7.35. So this is the thing due to the surcharge. Q value is 15. So this is due to the surcharge. Now we can take due to the, we have a surcharge here that is given in the question. Okay. Now due to the weight of the soil, now we have to take. No, we have, see, we have drawn for the both layers now, not only in the first layer. Impact on the first layer is 5 kilonewton per meter square. Impact on the second layer is Ka value of the second layer into Q. Okay, Prachi, properly check it. I think your live video is lagging something. Okay, check it. I have drawn for the second one also. Okay, now for the first soil, we have to draw the due to the weight of the soil. So how it will come? Ka into gamma into H. So it will come like this. That will be Ka into gamma into H. Ka means what? Ka of the first layer, gamma of the first layer, H of the first layer. We are drawing one by one. Okay, separately I'm drawing. I'm not going to draw for everything. What is Q in the question? It is given. Okay. See, surcharge of 15. Okay, first I'm drawing due to the surcharge. Okay, properly listen what I'm telling. Q is nothing but surcharge. Given in the question 15. So 1 by 3 into 15 is equal to 5. Similarly, Ka2 0.49. 0.49 into 15 is equal to 7.35. Is it clear now? Okay, if Ka of both the layers are same, then same value will come in the first layer as well as in the second layer. For all the layer, effect of surcharge will be there. What will be the effect of surcharge in each layer? Surcharge into the active earth pressure coefficient or passive, whatever it is, at that particular layer. Yes, you have to take it. Okay, Prachi, understood? So, and due to this effect of soil, Ka into gamma into H of that particular layer we are taking. So what it will be, this one? Just solve it. What will be that value? So Ka1 into gamma 1 into H1 will be equal to, for the first layer, 1 by 3. Gamma is 18. That is very important. While substituting gamma, either it can be dry or it can be saturated or it can be submerged condition, that you have to check. If it is under submerged condition below the water table, we have to take gamma submerged. If it is not under water table, then the bulk unit weight. Bulk unit weight can be either dry or submerged, whatever, or saturated, whatever they are giving. Maybe due to rain and all, it can be saturated. Whatever they are giving, we take as it is. Okay. So here they have given 18. So 18, it is under dry condition. 18 into H1 is how much? 2 meter. Calculate and tell me how much is this. Are you getting 12? 11.88. Okay, see, this is why. If you are taking 0.333, then you are going to get some answer. If you are taking 1 by 3, that is the accurate answer. Now, you are going to get exactly 12. 6 into 2. So better take 1 by 3. Why to take 0.333 and not? Okay, just make it accurate. So this value you are going to get 12. Enough? So the same thing we have to take for the other one also. See, because of this sand, what will happen? Because of this sand, weight of the sand, gamma into H, it is having an effect on the second layer also. Are you understanding, guys? This gamma into H we have taken using for Ka. Similarly, this gamma into H, this weight of the soil, weight of this sand layer will be having an effect on the whichever layer is there below, it will be having an effect. What will be that effect? What will be that effect? Gamma 1 into H1 will be having an effect on the second layer, Ka2 into gamma 1 into H1. Is it clear? We have taken the effect of Q. So Q into Ka1, Ka2. Similarly, effect of this sand layer, gamma 1 H1 into K1, gamma 1 H1 into K2. Okay, similar to Q. Clear? Only thing is it keep on varies. But for Q, it will be constant. That is the change. Clear? Okay. So here, sorry. Here it will not be like this. It is the effect of the second layer, no? Like this. Okay. Properly check it. Throughout it will be same because it is the effect of the upper layer. It not keep on varies. It will be a triangle portion only if H is varying. Here H is not varying. Gamma 1 into H1 into K2 of the second layer. Okay, so calculate and tell me how much it will be. Ka2 into gamma 1 H1. So 0.49 into same value. Okay. As of now, we have not taken anything of the second layer except the Ka value. Please calculate and tell me how much it will be. 17.64. Thank you. Understood? Are you following me? Are you following me? Yes. Thank you. So as of now, we have taken the effect of surcharge. We have taken the effect of sand layer also. Now what is remaining? Now we have to take the effect of C5 soil. How we have to take effect of, see, everything I am drawing separately just for your understanding. We can draw everything together also, no problem. Effect of a particular soil in that soil will be always triangular like this. What will be that value? Obviously, Ka2 will come in the second layer. Ka2 into gamma 2 into H2. Okay, because for this C5 soil, this layer is not having any effect on the upper layer. Okay, it will come down only now. Load values. So what will be this? Everyone calculate and tell me. Ka2 gamma 2 into H2 will be, what will be the gamma value? 20 minus 9.81. Okay, below the water table we have to take the submerged unit weight into 4. How much it will be? Calculator, tell me. 1 second, 1 second. It's a C5 soil, na? Sorry, it's a C5 soil. So whenever it is a coarse soil, small mistake. Whenever it is a coarse soil, how will be the pressure distribution? The pressure distribution is going to be something like this. If it is active, if it is passive, then everything is positive. So what change will happen? If it is a cohesive soil, on the upper layer, see, we'll be having a distribution something like this. On the upper layer, if it is an active, we have minus 2c root Ka. Here we'll be having Ka into gamma. Sorry. Yes. 1 second. Ka into gamma h minus root c 2c root Ka. If it was passive, then everything is positive. 2c root Kp and Kp gamma h plus 2c root Kp, like that it will come. Okay. Since it is a coarse soil inactive, it will be minus will come on the top layer. So you just calculate what is happening in the top layer and as well as in the bottom layer. So coefficient value they have given in the question or not? Coefficient value is given 12. Ka value will be 0.49. So calculate and tell me what is happening in the top layer. Minus 2 into C is 12 into root of 0.9 will be minus value you are going to get. How much is that minus value, guys? Is it 16.8? Is it 16.8 minus? Okay. You calculate for the bottom layer also. How much you are getting? 0.49 into now 20 minus. How much is that? Say 20. Na? Gamma is 20. So 0.49 into 20 minus 9.81 into 4 minus 2c root Ka you already calculated here. Yes. So how much you are getting for the second one? Bottom layer? 3.17. Okay. Are you getting the same answer? Everyone please check. If it was passive and all, if they are asking, then above also it will be plus. On the right hand side only it will come, not left. So plus 2c root Kp. Here also gamma Ka gamma h, sorry, Kp gamma h plus 2c root Kp will come. What is the equation of passive earth pressure? Reciprocal of Ka. 1 plus sin phi divided by 1 minus sin phi. If it was passive earth pressure. Okay. Now, are you getting the same answer, everyone? Okay. Minus 16.8, 3.17. So here we have minus 16.8. So it is in the bottom layer now. So I'm minus 16.8, 3.172. Correct? All are getting? Should I consider anything else? Is it over or should I consider anything else? Tension crack, maybe a tension crack equation I will tell you. As of here, we don't have to calculate the tension crack depth and all. This minus is coming. Tension crack will happen in case of active earth pressure because of this minus value. Minus thrust is coming now. So tension crack concept I will tell you. That is happening only in the active earth pressure case. That too in the clay layer because of this minus thrust. Should I take anything else? Should I take anything else? Very good. Effect of water also we have to take. See, effect of water table will come in two places. One is while taking the gamma value, we have to consider the submerged value below the water table. That is one effect to take a water pressure also, hydrostatic pressure also we have to consider. If gamma, I'm sorry, if you are getting any voice lag, if water table was not there, if water table was not there, in this equation only 20 will come, minus gamma 9.81 will not come. If water table was not there. Now, since water table is coming, this is one change. The other change is we have to consider wherever we have water table, we have to consider that hydrostatic pressure also. What is that hydrostatic pressure? Nothing but gamma W into H. So 9.81 into 4 will come. How much is 9.81 into 4? Calculate and tell me. 39.24. Henna? Pranay, we will see how much mark you are going to get finally. As of now, don't bother about it. You just practice questions. Okay, you will be getting mark. Don't worry. Are you getting, guys? Everything? Now what we can do, see, this is best to draw like this separately so that you will not make any mistake. You can draw together also, no problem. Now how can I draw? First you simply take what is happening in the first layer. Two things we have for the first layer, this and this. Enough? So top portion we have only 5. Bottom portion we have, which all things we have for the bottom layer? 12 and 5. Now, so here also we have 5. This is uniform. So first you just consider only the top layer. So on the top we have 5, on the bottom we have 5 in the first figure, we have 12 in the second figure. Here we have 0. No? So like this it is going to come 5 plus 12. Totally it will be 17. Is it clear till now, everyone? Till now it is clear? Enough? Now in the bottom layer, now I am drawing. In the bottom layer, which all portion I have for that particular layer? For the bottom layer, 7.35 at this point. Then for the bottom layer, which all things I have drawn? This thing also constant, 17.64. So 7.35 plus 17.64 minus 16.8. What all things will come? Tell me how much it will be. 7.35 plus 17.64 minus 16.8. How much it will be? Everyone please calculate and tell me, so that I can just confirm my answer. Yes, are you getting 8.19? Okay, good. So here it will be 8.19 will come. Which means from here only my next figure is starting. Are you getting 8.19, everyone? Yes. Now what will be on the bottom layer? We have 7.35 here also. So 7.35 plus 17.64, plus 3.172 plus 39.24. So 4 values will come at the bottom layer. Yes. How much it is? Calculate and tell me. Bottom layer. So this value, this value, this value, and this value in the bottom layer. Are you getting 67.4? Are you getting 67.4? Are you getting this answer? Everyone please tell me. See, either you can draw everything in the same figure or separately. Drawing separately is the best thing so that you will not make any mistake. It's up to you. How, in whichever way you have studied, it's like that you can study. Are you getting 67.4, guys? Yes, Krishna, you can do it, no problem. Okay, just to let you understand. If you're simply doing like this, then also fine, or you can separately calculate for each diagram, you can separately calculate, it's up to you. Okay, now if we are drawing like this, then now it is very easy to draw the, calculate the force, active earth pressure force, simply the area of this active earth pressure diagram. What will be the area? We got 2 polygons. Okay, so you can just calculate a plus b by 2. A plus b by 2. Yes, that's it. If you are separately calculating it, you have to calculate this depth also, tension crack depth. You have to calculate. So many calculations will come. So why to do that? Better you do this only. Okay. So 5 plus 17 by 2 into 2 plus 8 plus 19 plus 67.4 by 2 into 4. We are getting 2 individual shapes. We can easily calculate it. 2 polygons we are getting. Yes, very good. Very good, Pushbu. All are getting 67.4. So how much will be the active earth force now? Everyone, please tell me how much you are getting. Into 2 meter plus 17 plus 67.4 by 2. Correspondingly, it is 4 meter. Now tell me how much you are getting, everyone. Please comment. 173 are you getting, everyone? 22 plus 151. 173.1 around. Depends on your answer. All are getting same? Please let me know. All are getting the same answer? Yes, very good. Now see guys, very important. What is the unit of this 5 and 17 and all? This is kilonewton per meter square. We are multiplying with the corresponding depth of soil. So we are getting kilonewton per meter. Very important in the question. Sometimes they will ask what is the active earth pressure. What will be the active earth pressure? If they are simply asking you what is the active earth pressure, it means they are going to ask you at a particular layer. Okay, they can ask you either at the topmost point. So answer will be 67.4. Okay, so either they can ask you what is the active earth pressure at a particular layer, or they are asking you what is the active earth force. If they are asking you active earth pressure, then calculations are going to be much simpler. We just have to calculate only for the bottom. We don't have to calculate what is happening in between. Okay, now the thing we have to note down very clear. If they are asking what is the active earth pressure in kilonewton per meter, what is the active earth pressure in kilonewton per meter, which means they are asking you the force. Very important. Properly look at the unit in which they are asking. Kilonewton per meter means actually force per unit length. Okay, force is kilonewton per unit length means per meter. If it is simply active earth pressure, then it will be kilonewton per meter square. If they are asking in kilonewton per meter square, which means that is stress or pressure. Understood? This thing you just note down in which unit they are asking. They are asking in per meter, which means they by that unit they mean the force. Clear? Yes, that's it. Okay, Krishna, properly check it. See guys, if they are asking, look at this. I will show you another. All are getting the answer now? I will show you something else. Now see, whenever we have a cohesive soil, we will be having a shape like this. I already told you that is in active case. In passive case, we'll be having everything on the right side. Okay. In passive case, we'll be getting the figure like this only. In active case, we will have a figure like this. This we call it as depth of critical, what we can call critical depth or depth of tension crack. This we can calculate using this equation 2c divided by gamma root Ka. We can use this equation also. Krishna, you do one thing. Might be you might have made a mistake in this gamma value. You check it, okay? Gamma value properly check it. See, whenever they are asking what is the active earth force before tension crack for that particular soil only, okay? Active earth force before tension crack, active earth force after tension crack. We can directly go for this equation. And many of the time they asked in many competitive exams as well as in GATE exam also recently, they asked what is the change in effective stress, what is the change in active force, active earth force before and after tension crack. We don't have to calculate everything. You just calculate this term if they are asking you what is the change in active earth force before and after tension crack. Okay, properly noted. Here there is a square. Maybe for some of you in if you are a TGS student, if in LMS somewhere I have given a reply where I forgot to put this square value, half Ka gamma H square will come. Okay, please note that only active earth pressure is going to increase because of the tension crack by an amount 2c square gamma, that you just note down. And this is what I told you. What is this H actually? What will be the depth of an excavation without any lateral support? 2 times this depth of tension crack, it will come 4C divided by gamma root Ka. Okay, so you just check it whether which gamma we have to use. You just check it, you will be getting the answer. Okay, we have to properly check what is the difference between this depth of excavation and the depth of excavation we have studied before for no heaving. You know, in part 2 we have studied this is for without any lateral support, how much depth we can excavate in a cohesive soil. We have to take 2 times the depth of critical, the depth of tension crack or critical depth. Okay, right. Krishna, which gamma value you have taken? You might have, that only the mistake you might have made. So properly take this one. I think, yes, you do a question for this also. We may not be having much time to solve everything. The remaining question, whichever I was planning to give you, what I will do, all these PDF, you will be getting it, or you will get in the description box of each video. Okay, now we have to upload it after the class. So what I will do in the remaining, whatever questions is pending, okay, which I was planning to take for you, that what I will do, I will solve that, and that PDF I will upload in the comment box, okay, as a PDF, so that you can see the remaining questions which I was planning to give you, and also you can just compare your answer. Don't worry, okay, since we lost some time in between, I will do that. Okay, I will not simply skip those questions. I will write the solution, then I will upload the PDF. Okay, so that you can just compare. We just do this question. So that one point I can tell you here, one important point I can tell you here. Rubesh, if you are in first year, then it will be difficult for you, because in first year we are not actually going into the civil engineering now. We are just studying everything, physics, everything you may be studying. You can just have a look into mathematics and all. Okay, in first year, if you start preparing, it will be difficult for you. Okay, you can just have a look. Something you will understand. Everything you may not understand, but don't get depressed. That's what I'm telling. Don't get depressed after preparing from the first year itself. Maybe from the second year onwards, you can start preparing. That will be good. So just try to solve these questions. Then I will explain something. The remaining thing I can explain after some time. Guys, what was the answer for the last one? I'm sorry, 1 second. What was the answer for this particular question? Whether we have discussed it? Yes, 173. Was it there on the option? Yes, option B we are getting. Fine. Yes, now come back to this particular question and solve it. Yes, start solving it. I will tell you in which all area you may make mistake. Yes. Have you started solving it? Okay, you are getting. Okay. Thank you for commenting. Now just look at here. We have 4 different equations for the ultimate bearing capacity. For strip footing, for circular footing, for rectangular footing, and square footing. No need to by heart the square footing if you are getting confusion. If you are substituting B and L are equal, it is cancelling. So 1 plus 0.3 will come. Here B and L are cancelling. So 0.8 will come. 0.8 into 5 will be 0.4. Okay, so rectangular and square, you can remember anything, no issue. But remember for circular footing as well as for strip footing. And what I can tell, yes, for a circular footing, B means our diameter. Okay, you can put diameter here, it's up to you. But it is not the depth, that's why I have not put a D here. In the second term, D is the depth, but in the third term, B is the width. For a circular footing, width means we will take diameter. Okay, in the third term, that's it. Now here they are asking us for a circular footing. So we have to use the second equation, 1.3 CNC plus gamma D and Q, that one. Okay. So QE is equal to 1.3 Now tell me what value you have substituted for NC and C. Tell me that. What value you are going to substitute for C and NC? That is the only thing we have to discuss here. All other thing we can easily calculate. C equal to, how much they have given C equal to? First of all, where it is, the cohesion value of the soil is found to be equal to that for a pure clay sample having unconfined compressive strength. Purposefully, I was making little bit lengthy. What do you mean by unconfined compressive strength? We have a UCC test, unconfined compressive test. In unconfined compressive test, we will be getting C is equal to Q by 2, where Q is nothing but unconfined compressive strength. So in majority of the case, they may not be giving you the cohesion directly. Sometimes they will be giving you the unconfined compressive strength in the equation. Unconfined compressive strength. This is actually we are getting from a UCC test. Unconfined compressive strength test is there from there. Sometimes they will give this. Sometimes they will give undrained shear strength. Undrained shear strength. If they are giving these two, what you will do? C value is equal to unconfined compressive strength divided by 2, and it is equal to undrained shear strength. This is very important to just note down. Instead of giving you the C value, what they can do, either they can give that is equal to the cohesion of an unconfined compressive strength, they can give like this. Then we have to take divide by 2. Generally, if it is a clay, okay, then undrained shear strength. If it is a sand, then it is equal to 0. C value 0. If they are giving undrained shear strength, we are taking equal to that of C. So look at here, what they have given. Undrained compressive strength now is equal to 30. Actually, I made another question. That's what I told you. That I will give you as a PDF later. Here I might have put it as where it is. One second. Okay, let it be. That was sand only. Okay, no issue. Okay, that you can calculate. Later I will give as a PDF. So here, what I have to take, what will be the C value? Tell me what will be the C value here. What will be the C value here? Very good, 15. Enough. So if I am substituting 15, if I am going to substitute 15, then I am going to get wrong answer. This is what you have to just check. Yes, C is 15 only, but you always have to check whenever they are asking for a shallow foundation, whenever they are asking what is the ultimate bearing capacity and all, we always have to check what is the angle of internal friction. Let's look at here. What is the angle of internal friction? What is the angle of internal friction? 20 degree. Whenever the angle of internal friction is less than 28 degree, then we will be having local shear failure condition. Under local shear failure condition, we have to use the mobilized value of, values of shear strength parameters. What do you mean by mobilized value of shear strength parameters? We have to take C dash or Cm, or we have to take phi m or phi dash. What is the meaning of this? If the given value of phi is greater than 28, we can directly take C is equal to 30 by 2, which is nothing but 15, and whatever NC value they are giving correspondingly, we can take it. If they are giving a value which is less than 28 degree, either they can give like that, or they can tell in the question, assume local shear failure. If it is greater than 28 degree, that shear failure is known as general shear failure. Okay, general shear failure. If it is less than 28, even though they are not mentioning, we have to consider a mobilized value. What are those mobilized value? Just remember, the mobilized cohesion is equal to, it will be reduced, okay, 2 by 3 of the C value. Okay, C value is nothing but, C value is nothing but 15 only, but the value which we are going to take in the equation will be mobilized value 2 by 3c. Similarly, your mobilized value of angle of internal friction phi m will be equal to 2 by 3 of tan phi. Okay, so we can calculate what is phi m, tan inverse 2 by 3 tan phi, like that it will come. Okay, we can calculate it, don't worry. Okay, why we have to calculate tan phi m and all? Here we don't have to substitute. So this one we don't have to calculate. Simply, can you tell me how much will be phi m then? Can you please calculate phi m and tell me? Okay, first you just tell me how much is cm. 2 by 3 of 15. That is going to be 10. So here we are going to substitute 1.3 into 10. Can you tell me how much is phi m? We don't want to substitute phi m here, but still, can you tell me how much will be phi m? Tan phi m will be equal to 2 by 3 tan 20 degree. So how much will be tan 20? Tan 20 into 2 by 3. You are going to get 0.242 something. So phi m will be tan inverse 0.2242, that one. Right? Now tell me how much will be phi m then. Can you please calculate and tell me how much is phi m? 13 point. Yes, thank you. 13.693. No? Sorry, 639. We don't require here. Actually, what we are going to do, we have NC value, we have NQ value, we have N gamma value. You know, these NC, NQ, N gamma parameters are actually corresponds to different values of angle of internal friction. If you have 10 degree, then we have different NC value. If you have 20 degree, different NC value. If you have 30 degree, different NC, NQ, N gamma value, like that. Okay. Now listen, if it was a clay, then NC value, NQ value, N gamma value are constant. That I will tell you after some time. They have given that for phi, NC value is equal to this many set. So can I use that value now? Can I use that value? No. Now what we have to do? We have to use the phi values for 13.639 degree. Correct now? We have to use phi value for 13.639 degree. That is nothing but they are giving that NC dash, NQ dash, and gamma dash. Clear? Which is nothing but these are actually the NC value of phi equal to 13.639. So either they can give, in two ways they can give, either phi equal to 20, they can give NC and NC dash, or in the question they can give NC value of 2, 3, 4 different angle. Phi equal to 25, NC, NQ, and gamma. For phi equal to 20, NC, NQ, and gamma. For phi equal to 13.639, NC equal to 11.8, 3.8, 1.3. For phi equal to 10, they can give different. So from the set of value, we should understand which NC, NQ, and gamma we have to select. Is it clear, guys? Is it clear? Is it clear, everyone? Please type yes or no. Clear or not? Yes. Understood? So which NC value you have to substitute now? 11.8. Clear? Yes. So substitute the 11.8. Proceed now. Everything you proceed and tell me how much you are getting the answer. Please check whether it is under submerged condition or not. If they are giving any water table is at the ground level or something. Anything like that? Nothing now? Yes, nothing is there. Okay, so everything will be exactly whatever they are giving in the question. Gamma submerged is given or not? Sorry, gamma saturated is given or not? Unit weight of 22. So we are going to take exactly 22. Okay. If they are giving that water table is at the ground level, then 22 minus 9.81 will come. That is the only change. Now substitute everything. 22 into 2, placed at a depth of 2 meters. So 22 into 2 into NQ value, nothing but NQ dash 3.8. 0.3. This is what I told. What they have given, is it a square or rectangle? Yes, square footing of 4 meters. If it was a circular footing of 4 meter diameter, then we are going to put there also. Okay. So I'm sorry, it is a square footing, no? 1 second. Yes, square footing equation we have to use. I think I made some mistake. 1 second, guys. Okay, according to my calculation, actually I have taken. Okay, it was a square footing. I calculated based on the other equation. No problem. We have to use 0.4, according to square footing, 0.4. Okay, you calculate then and tell me what is the answer so that I can compare. And gamma value they have given in the question itself, 1.3. Guys, tell me how much it is. Everyone please comment. Everyone please comment how much you are getting. Yes, final answer, Krishna. Yes, you are correct. Very good. Tell me how much is QU, then you should be getting 320, no, 366.36, Are you getting the same answer for QU? QU, yes, very good. Okay, now what we need to do, if they are asking what is the ultimate bearing capacity, guys, we may take maximum 5 more minutes. Okay, maximum 5 more minutes we may take, then we'll finish. 1 second. Okay. If they were asking what will be the ultimate bearing capacity or gross bearing capacity, that is our answer. Okay, this 366 is nothing but our gross bearing capacity or ultimate bearing capacity and all. Okay, or if simply if they are asking what is the bearing capacity and all, okay, ultimate bearing capacity, that is the answer. Once they are asking what is the safe bearing capacity, what we have to do, we have to divide with the factor of safety. Okay, one more thing I'm telling you. If they are asking you what is the ultimate bearing capacity or what is the gross bearing capacity, this is the answer. If they are asking you what is the net bearing capacity, if they are asking you what is the net bearing capacity, what we have to do? Ultimate bearing capacity minus gamma D we have to do, which is nothing but 366 minus 36 minus 22 into 2. This is our net bearing capacity. Now, if they are asking you what is the safe bearing capacity, what we need to do? We have to divide with the factor of safety. Enough? So we got QU is equal to 366.36. So if we require Q safe, theoretically speaking, we can do like this now, but we will not do like this. This is wrong. You shouldn't do like this. What you have to do, if you want to find the Q safe value from this, first we have to calculate what is Q net. Then we will divide with the factor of safety. Then again we will go back to this one. What we are actually doing, we are minusing gamma D and we are making Q net. Then we will divide with factor of safety. Then we are going to add the gamma D value. Or simply if I am telling only Q net value, QU is equal to Q net plus gamma D. Like that we can write now. So if you want to find the safe value for this, we will calculate only the safe, divide with factor of safety only the Q net value. Then we will add gamma D like this. Okay. Is it clear? Is it clear? So that you calculate then how much will be the safe bearing capacity. Safe bearing capacity will be now 360.36 minus gamma D you have to calculate, which is nothing but the net net bearing capacity divided by factor of safety. Then you have to add gamma D. Now tell me guys how much you are getting. Net ultimate value you are going to get 322.36. Factor of safety they have given in the question that 2.8 plus 22 into 2, not 44. Please comment how much it is, everyone. 159.2. Okay, very good. Are you getting the same answer? Kushbu, please check your calculation. 150. Okay, you might be telling this one now. Please check the calculation. Getting? So is this my final answer? Is this my final answer? What will be the safe bearing capacity? If they are asking what is the net safe bearing capacity, then what you will do? If they are asking what will be the net safe bearing capacity, this is the net safe bearing capacity. Net safe bearing capacity is that one. If they are asking you what is the gross safe bearing capacity, or by default, if they are simply asking you what is the safe bearing capacity, it is nothing but your gross safe bearing capacity. We have to do like this. Clear, guys? Now, is this my final answer? Is this my final answer, 159? Very good. No, because they have asked in kilonewton. Always look at the units in which they are asking the question. Whichever be the subject, always look at the unit they are asking. So safe bearing capacity, they are asking in kilonewton. What is the meaning of this? Either we can represent the safe bearing capacity in terms of kilonewton or newton or whatever, or per meter square term. In this equation, we are getting in terms of per meter square always, because see, gamma into D, NQ and gamma NC is not having any unit. So gamma is kilonewton per meter cube into D is in meter, kilonewton per meter square. So how can we convert that into kilonewton? Multiply with the area of the footing. So how much it will be? 159.2 into, they have given that it is a square footing. Square footing size is 4 meter side. So into, how much it will be? Yes, very good. Into 16. Enough? Into 4 is the area. Now tell me, guys, how much is the answer? Are you getting the same approximately? Are you getting the same approximately? 2546, 2547, whatever, everything will be correct. Clear? Is it clear, guys? Okay, very good. Understanding? If they are asking net safe bearing capacity, we don't have to do this plus gamma D. They are asking gross safe bearing capacity, or by default safe bearing capacity means gross only. Then we have to take that also properly. Remember, the very important thing is this mobilized value of cm and phi and all. They can ask you simply what is the mobilized value of what is the mobilized shear strength parameters, that they can ask you. Okay, that you properly check it. And this question I will ask that, see here, can you please look at the question and tell me, will you take NC or NC dash? Will you take NC or NC dash? Can you please look at the question data and tell me? No need to solve now. We are going to end the session. This I will give you the answer as the PDF. Will you take NC or will you take NC dash? How can you tell NC dash? You simply tell me NCD or NC. What will we take? Yes, very good. NC we are going to take because here phi value is greater than 28. This is actually the NC values of phi dash, okay, or phi m. Okay, these values are actually predefined values. Okay, one extra point I can tell you, not for this one extra point. For a clay layer, always your NC value will be 5.7, your NQ value will be 1, your N gamma value will be 0. It is fixed for a pure clay. Why? Because for a clay, your phi value will be always 0. I told you for each phi value, we have a set of value. For phi is equal to 0, NC is equal to 5.7, NQ is equal to 1, and gamma equal to 0. It is not for this question. In general, I am telling. Okay, so if they are giving that it is a clay layer, they will not give you NC, NQ, and gamma. You have to take from this. Okay, guys, very good. So this solution I will give as a PDF. You can solve it. Then I have just made a question for pile foundation also. That also I will give you, that you can check. This question was actually I wanted to give you for capacity of a pile. That also you can check. You can solve it. I will give you as the answer. Then this is not that much important. This is particularly a theory only. not that much important, but 1 or 2 years they have asked. That also you can check. We have a sampler. This is the dimension of the sample. They will give like this. This is the cutting edge. Cutting edge sample outer diameter is D2. Inner diameter of the cutting edge is D1. For the sample for the sampler. Okay, this is sampler. For the sampler, inner diameter is D3. Outer diameter is D4. So by giving all those things, either they can give a figure like this, or they can give D2 is outer diameter of the sampler, cutting edge, outer diameter of the cutting edge, and like that they can give the values, and they can ask you the inside clearance, outside clearance area ratio. And for an undisturbed sample, this value should be less than, okay, if it is in percentage, we have to multiply with 100. Okay, so that also you can remember. These are direct, not that much important, but you can simply remember. Okay, right. So for the other question, you can just refer the PDF which we are going to upload. Okay, so if you have any doubt, you can ask in the comment box anytime, no problem. I will reply you in the comment box. And if you are a TGS student, then TGS students are getting an opportunity in their LMS. You can ask in the LMS or below this video also. Then I will comment. Don't worry. Okay, I will be regularly checking it. Guys, so shall we wind up the session? Yes, actually, we have started uploading it only for the previous video for the transportation, geotech, everything, hydrology, irrigation, for all the things. Now we started uploading in the description box. Okay, not in the comment box. In the description box, you will be getting that link. Okay, so just check it in the description box. Now onwards, it will be available. Okay, right? So shall we wind up? So thanks for joining. If you have any doubt, you can just ask in the comment box. PDF we are going to start upload now in the description box. You can check it. Right. So thanks for joining. So wish you all the best for your GATE exam. What I'm telling, suppose you don't know any concept, now don't go behind that concept and spend your time. One more thing I'm telling, this time they have added few concepts. Now, don't think that definitely they will ask those concepts. Nothing like that, because previously they have updated the syllabus in 2016. In 2016, they have introduced the railway engineering. They have introduced airport. They have introduced the in surveying, topographic survey, like that, engineering mechanics, like that. So many topics they have included in 2016. Finally, they asked only one topic, which is topographic surveying in surveying subject. They didn't ask anything in railway. They didn't ask anything in airport. They didn't ask anything in engineering mechanics, like that. So something added doesn't mean that 100% it will ask. They may ask, they may not be asking. Okay, so don't need to spend an entire time on that extra added topic. If you're not understanding anything, simply skip it. Don't worry. Right now, you spend time for those who have already studied those concepts. We already studied and revise it. That's what you have to do now. Okay. Right. Okay. So don't invest time for new concept now. Now onwards, you invest time for revision. Okay. Because what is happening in the examination hall, everyone will forget the equations and forget the things we studied and make mistakes. Instead of taking gamma submerged, you may take gamma. Instead of taking, or see in the last question, the gamma W value you may not be taking. Mistakes you may make in the examination hall. So not to make that mistake, what you have to do, you have to revise the things you have studied already. So do that now instead of studying new concept. Okay, for all the so prepare well. All the best. Whenever you have doubt, you can just ask in the comment box. Definitely all the faculties will be replying. I will also reply for transportation, hydrology, irrigation, and geotech as well. Okay. So by now, we have already taken so much time extra. So I hope you enjoyed the session. If you have enjoyed the session, give your love back or your feedback in terms of likes and comments. Share the link with your friends also. Subscribe the channel and click on the bell icon, so that whenever some videos are happening, you will be getting the notification. Okay. So thank you so much. Thanks for joining. All the best. Have a good day. Thank you.